Depeche Mode took us to a sea of love with Strange Love. The Cure took us into the sea with Love Cats. The Eurythmics Want to Dive into Your Ocean. Susie and the Banshees carried us on sea breezes. But it's Ocean Rain from Echo and the Bunnymen that feels most like Apsec's sad longing for success with the lyrics, "My ship's a sail. Can you hear its tender frame screaming from beneath the waves? Screaming from beneath the waves." Which means this week we talk with Peter Klimek from Imperva about navigating the seas of security and serverless functions, how they can benefit security and how to keep them from hindering it. In the news segment, 25 CWEs float to the top for 2021. Sequoia rides the wave of integer overflows, a sinking feeling for 2FA adoption, clouds on the security horizon, and more. All hands on deck, and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. In any business today, there comes a moment, the moment you realize you can secure the code as fast as you write it. Instead of testing everything, you can just test the right things. It's not about tools, but intelligent risk management. That's the moment you choose Synopsys. Build secure, high-quality software faster. Visit securityweekly.com/Synopsys. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
This is episode 159, recorded July 26, 2021. I'm your host, Mike Shima, and as always, I'm here with John Kinsella. Hello, John.
Good morning. I'm here to talk about your policy of truth, or you prefer I'll be your professional Jesus. Excuse me, your personal Jesus. Although I have to say, now I think about it, I prefer professional Jesus.
People are people, John. Why should it be that you and I, we do get along great. We get along just as great as Cyber Risk Alliance does with InfraGard, because they have launched the Critical Infrastructure Resilience Benchmark Study. Measure your readiness for ransomware by completing the survey and getting your score. Take the survey at securityweekly.com/CIRB. Do you want to stay in the loop on all things Security Weekly, especially keeping up with all the Depeche Mode lyrics we can get into one episode? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch. Peter Klimek is Director of Technology within the Office of the CTO at Imperva, a market leader in edge, application, and data security. Peter helps global customers protect their applications, data, and websites from security threats through all stages of their digital journey. Prior to Imperva, he held roles at Kaspersky, TransUnion, and Zebra Technologies as a solutions architect, security analyst, and engineer. Hello, Peter. Thank you for joining us, and welcome aboard.
It's an absolute pleasure to be here.
Well, we're glad you're here to, as we hinted at, navigating the seas of serverless functions. And I do just kind of want to start off with one of the things that I think appeals to me most about the serverless concept, or the push towards it, because fundamentally, instead of dropping a whole application into least privileges, we can actually get more granular with the concept of least privileges to specific functions within an application. So this particular function just has read-only access. This particular function has write-only access, and so on. I think serverless helps us get there, but I'm not sure how easy it is to get there. So maybe let's start that journey with a little bit of just what some of the benefits you've seen of serverless, and what are the good aspects of it that you like to point out?
Yeah, so I think the main reasons why we see developers switching over to serverless, there's really a couple big ones, but I'll start with the big one and the really obvious one here. It's really all in the name itself. I think by and large, the vast majority of developers, they just want to write code and run code and not really have to worry about the underlying infrastructure. And we've seen this dream kind of over the years with services like Heroku and some of the PaaS services. And I think serverless and things like AWS Lambda have really become more of just an extension beyond that, where it just gives you the ability to take a single bit of code and then just be able to run it up in production, not have to worry about provisioning or managing the underlying servers or infrastructure. I don't have to worry about patching those underlying servers. And so that gives developers a lot of flexibility and freedom just to really focus on the core aspect of what they're actually writing. Above and beyond that, when you factor in additional things like the fact that it is per millisecond billing and basically gives you the ability to really go and only run code when it's actually, or only pay for code when it's actually running, it's something that's very attractive for a lot of organizations to be able to start switching to.
Yeah, I think you definitely hit it right off the bat there too. With one of the other things is that nowadays, especially with cloud native, DevOps teams are expected to be experts on network, on connectivity, on backups, on IAM policies for that matter, which can get really confusing. But at least in serverless, as you pointed out, they don't have to be as much experts and taking the time out of their day to manage the OS stack. So that's one thing that's taken care of. But as I did kind of allude to, the IAM aspect, it sounds nice, but that's also gets pretty complex. Have you seen that be a stumbling block, or are there more than just the trying to wrap your head around the complexity of IAM policies that can be stumbling block? I can't say that word today for DevOps teams to get into serverless functions.
Yeah, without a doubt. I think anyone that's ever gone and started to work with serverless functions in AWS, and as soon as it starts actually communicating outbound, the first thing that you run into is this, nature of IAM policies, as well as actually some of the more complex networking related aspects of it. I think everyone's first kind of hello world of serverless always runs in kind of AWS's public shared compute environment. You don't really have to worry about those things. But as soon as you start dropping those serverless functions inside of VPC, you have to start worrying about some of the network routing that actually gets set up between those VPC endpoints and actually communicating outbound to AWS services. So you start having set up things like VPC endpoints. And then the IAM policies themselves actually become more complex in that scenario as well, where previously you might have decided that, well, we're initially provisioning and running in the AWS environment. As soon as we move it into a VPC, now we have to worry about things like, do I have IAM permissions to provision and deliver an ENI associated with that instance? And so the permission model starts to get a lot more complex. And after about 20 times in iterations of you trying to start this function and it not working, a lot of times what a lot of developers will just go to do is just say, star, and they put that asterisk in there, which is effectively the network equivalent of an any firewall rule, and just to get the thing up and running. But ultimately what we end up finding is that those serverless functions become over provisioned with entitlements to basically access resources and to manage different other resources within AWS.
Yeah, I think that's one of the dangers, is that it can introduce the idea of bringing serverless to encourage good architecture is good behaviors of just focusing on the code that you want to write and run rather than having to focus on the OS or a lot of complex network connectivity. It can have those throwing a star in there. I'm also curious how you've seen, is there a difference in how you've seen DevOps teams approach serverless? And what I'm coming at from this perspective is building serverless from the start, if you will, just saying, here's a type of app that we think would fit well for it, versus the idea of decomposing a lot of these ancient monoliths that have built up over time. And so you're going from one big service into perhaps a sprawl of a lot of different services. I'm just kind of curious if there's a different approach there, different concerns, or sort of like serverless concerns or serverless concerns. And here's a couple things to keep in mind.
There's definitely really big concerns with it when you start actually going and looking at it from both sides. I think for most organizations, they usually start out with maybe just a small independent use case, and they start to develop based on that. And so the nature of serverless functions is that, unlike kind of traditional web applications and some of the other environments, serverless functions tend to be more event-driven in nature. And so oftentimes what you're doing is you're using them to actually respond to different types of events that happen off the network or outside of another AWS service. So, very simple example is always that a file gets posted or put to an S3 bucket, and I need to go and I need to do something to that. That's probably where we see most people really starting with serverless. They see how easy it is for them to process and to manage that one individual use case and to kind of handle those triggers, and they go a little bit deeper into it. As you go further in that journey, though, I think probably the first thing that people start to realize, though, is by virtue of you decomposing everything and running it into lots of individual functions, it becomes a lot more complex to manage. And one of the most important things around that then is that you have to start looking at frameworks to help you manage that sprawl of all the different code and services. In the early days of serverless, there really wasn't much out there, and people were kind of just running those small functions. But as the complexity started to increase, we started to see the introduction of things like the serverless framework, which is an open source framework that helps you manage and connect all of those pieces together, as well as we've seen now the introduction of things like the serverless application model and CDK templates and all sorts of other frameworks that are out there to really kind of help with this.
Yeah, I think one of the aspects too is that, especially you're hitting at that complexity, needing to pull in frameworks, is one, it's important to figure out what framework is appropriate for that. And I'm curious too, are there, I don't want to be the type of AppSec person who comes and says, just move everything to serverless and you'll be much better. Sort of, what are some good things that might be appropriate for serverless where it can be really helpful, but other types of applications where you maybe want to pause and say, there's a different approach here, or there's a different framework you'd want to use, and serverless might not actually be what you want, the route you want to go?
Yeah, it really requires, I think, just a careful understanding of what you're actually trying to solve with it. There's a careful balance, I think, between when it's appropriate and correct to choose containers as kind of your primary runtime environment versus actually going down and looking at that serverless route. The serverless route, I think, ultimately, while it does give you that ability to kind of control things at a much smaller level, it isn't necessarily a panel in terms of how it's able to go and solve all problems. It introduces new complexities and new problems that you actually have to deal with. One of them that we pretty frequently realize very quickly is the ephemerality, the nature of these serverless functions, and the fact that they only run for anywhere from milliseconds to in many cases most of them are over within a minute or so, and then they start from their life cycle all over again. And so ultimately with those things, you have to now account for, well, how do we go in and how do we actually have the telemetry or make sure that we have the telemetry and everything that we need to actually go in and understand when something does go wrong, do we have the information that's really required to actually be able to go and perform an investigation?
Yeah, and I think that seems like a good point for us, a good detour for us to take, because I suppose one of the reasons this podcast is around, because we haven't yet figured out how to write perfectly secure code. So serverless functions might have insecurities in them. So let's start to pick apart a couple of things that might go wrong. And you were starting to take us down the route of ephemerality investigation, but before we get to that, let's also just talk about, what about different ways of handling security? I was talking about IAM, so identity and access management. But what about secrets? So, for servers to talk to each other, serverless functions may need to talk to data stores, for example, and hopefully they're doing that with some sort of mutual authentication, or at least some credentials. So what does secrets management look like? And especially in the spirit of, oops, there might be a vuln in here and what might be exposed.
Yeah, so from a security perspective, I think there's a couple of main things that have to be really considered. So let's start with secrets management, because I think it's one of the first problems that ends up getting solved or has to be solved across the board. Every developer should know, or I hope every developer should know. Every security professional certainly knows you should never check secrets into code or into your source control. And so by and large, that's always kind of a low-hanging fruit is, well, how do we establish this connection to a database or to other services that we have? There's a couple of different strategies that you can use. I think by and large with serverless functions, where possible, where you can use things like IAM policies to be able to manage and govern that access, you should absolutely do that. because that provides a simple way. You're not exchanging credentials. AWS kind of handles that magic for you underneath the hood. If you're not able to do that, so oftentimes when you're connecting to a database, for instance, you have to use some sort of connection string and username password. In those instances, there's really kind of a progression that we'll see for a lot of organizations. Kind of a better policy than checking it into code is certainly to use things like a configuration file or an environment variable that you're effectively pulling in at build and populating. It's still not a great solution ultimately. I think one of the big challenges that you see with serverless functions is that, and there's a little bit of a misconception of the fact that even though it's serverless and you're not managing server, there's still a server underneath. If you have an OS command, the ability to run an OS command, you can still run an env command and still print out all of the secrets and everything that are displayed there. So it's a challenge of environment variables just as a whole. And the better solution, and really, or I'd say the best solution, and what we really want to see people move towards, is using some sort of secrets management tool to be able to actually govern those secrets as you're connecting out. So AWS Secrets Manager is a great example. HashiCorp Vault is another great example. Using those as a mechanism to be able to basically manage your credentials and then to be able to enforce and perform password rotation. This is ultimately where we want to see organizations get to. And we strongly advocate, before you really go deep into that serverless journey, develop the frameworks and the usage patterns internally from your development teams for how you access and how you provision and build these functions to do that, before you go and basically sprawl out to hundreds of different functions and then have to retrofit them later.
Yeah, and so I think just to highlight really that key point of what you just said too is it's not so much just a shift to serverless, and serverless is going to solve things for us. It's more of, do you have a mature SDLC to support the change, the perhaps even small changes, but the change nonetheless of the design patterns you're going with in serverless. And I think part of that then also brings us back to that aspect of, oops, something went wrong and we need to investigate. And there's that ephemeral part. You can't really quite as easily go through and grab memory dumps, grab running processes. So what does forensics look like? What are some recommendations you have around observability, and it kind of, can it fall into instrument the code? Are there tools that can be running to augment what that serverless function is doing? Help us out a bit with some ideas about making code observable and visible for our devs.
Yeah, this will be the first problem that I think most developers will actually run into pretty quickly. They'll see, initially that everything is really just what they log in their functions, and then they use that logging as kind of their primary mechanism for it. But of course, we all know, we've all been looking at logs for years for developers, and what do they log? They log things that they care about, like business concerns and how well the function's performing. They don't log things like security issues. And so having a common starting point for that is a pretty important part of it. A lot of teams will use observability tools like APM agents, application performance monitoring tools, to be able to understand memory footprint and some of the other things. But it doesn't quite get to that level of really that security detail that we actually need yet. And this is another big part of serverless functions where we see security teams starting to struggle is, well, how do we get the data that's actually useful to us for this? And the good news is there are solutions now that basically are available to us with AWS in particular. I always kind of focus in on that one because it's just the furthest along. But what we strongly advocate for is running effectively a layer that effectively wraps all functions and provides that security telemetry that you actually require in order to basically go back in time and look at, was there anything malicious that was actually passed to this application? And so having those common core runtime layers that are wrapping all individual functions, that gives the security teams the tools and the visibility insight that they actually need to understand what actually happened at any given point in there.
Yeah, I think I'm curious to talk a little bit more about that, because to me, what really stands out of what you're describing is being able to say, here is a request that came in, and tracking that request and response pair across not just the one particular serverless function that might have served it or handled it, but there could be this complex fan out of microservices or serverless functions that handled that. So if you're losing this identity from one to the other of, here was the original request and here was the response that came back, and that response maybe has just an error, or it had indicators of cross-site scripting, SQL injection, RCE, data exfiltration, something like that. That's probably pretty bad. So I'm kind of curious, as you look at logs, are there certain things that you would highlight either as metrics to track or particular capabilities or perhaps use cases that are just really good to keep in mind for these developer teams as they say, well, we know we have this business context of what we want, and we want to be able to debug our own code to figure out what's going wrong. But what else might be out there that we should be perhaps proactively thinking of and enabling logging to do, so that we don't just turn on logs but realize we're unable to answer the questions that we want to ask?
Yeah, so I think you're going to see it from really kind of a couple different perspectives. I think for understanding that basically that hierarchy or basically the chain of all the different functions that get executed or called from one function to another, there's a great project that's part of the Cloud Native Computing Foundation called the Open Telemetry Project. And this really is implementing the concept of distributed tracing. And so it's helping you to understand what's actually happening as that function is calling out to other services. What does the latency look like? What does the various metrics look like? And of course, this is more on the performance monitoring side. But I think from a security team's perspective, the fact that it associates unique trace IDs or spans associated with each individual function, there's a lot of value to be able to start to tie those different pieces together and really understand exactly what happened. Then as we start to get into the actual function itself and looking for, well, what actually is happening here, what we strongly advocate for is to effectively look at it from the perspective of, I want to take really kind of apply a positive security model. And ahead of time, I want to say, this is how I expect my function is going to behave. It's going to be making these network calls. It's going to be making these system calls. And effectively outside of that, I don't want it to actually process or perform anything else. And I want it to trigger some sort of an alert if it does, or even just deny by default effectively in there. And then providing that level of logging information of, this is the exact line of code that did this. This was the request payload that actually managed to trigger this. That gives you really that insight and that understanding of not just how did the function actually go through that chain to actually get to the point, but then also exactly what was the request payload that ended up triggering that and seeing how that actually behaved. And that is really, I think, the best that you can hope for a security model as you start looking at serverless functions, is actually being able to stop it at the point of it actually happening within code.
So let's now broaden to more the ecosystem around perhaps security functions. And we've touched on this a little bit, but I think it's worth coming back to in the sense of forensics. You just gave us a good explanation of that, logging, for example. And you also got into that aspect of the maturity of your organization. And one of the things I'm kind of curious about is, not even maturity, but it's a simple AppSec assertion to say, have an app inventory or just have an asset inventory. Here's all of your running apps. I want to ask at this point, with that mind towards maturity or perhaps even just tooling, how are we managing our broad product or suite of applications? What does this look like from an asset inventory? Does either the cloud in general make this different, or can we say it makes it easier? And how do serverless functions look like? Do you see people treating them as, this is what we call our app, or our app is composed of serverless functions? And here I'm kind of getting not so much the idea of just nomenclature for nomenclature's sake, but just managing where all these are, and the idea of, could we have, unfortunately, shadow serverless out there, functions running that we don't know about that are increasing our attack surface?
Yeah, I'll start with that last bit there, because that kind of that shadowless serverless functions and things that could be really increasing your attack surface. That's probably, I think, the most concerning for a lot of organizations as you really kind of look at it, because AWS provides in-browser editors where you're able to basically go and edit code in line and publish that code immediately up to production, and to be able to start accepting requests coming in off of any individual environment. And so if you want to talk about, shortcutting the SDLC and all of the checks that we've put in place over the years, there's probably no easier way to shortcut it than that, where it's just like literally a web browser and then a couple quick buttons to click and deploy, and then you're pretty much done. And so for organizations, they have to really go and put in the processes and kind of the actual deployment pipelines and the testing processes. Otherwise, you're going to end up with that as a reality, which is a very scary prospect, I think, for all security professionals. In the broader, sorry, go ahead.
Just a quick on that one. That sounds like a good reason by itself to learn how to use Amazon's IAM, stuff, right?
Yes.
I don't know if you can hopefully limit down the DUI aspect, but I'd want to kill that one ASAP.
Yes. Yeah, and you can absolutely, there's controls, there's things that you can do to prevent that from happening. But if you don't do that, if you don't know that that actually exists as a risk, then I think that's probably something that people are just like, wait, I can just push code immediately and just click a button and that's pretty much it. And developers are like, this is the greatest thing ever. I don't have to go through all these other long, arduous processes. Security can't tell me no when I just click a button. So it's definitely probably high up on that level of risk that you have to think about. But more broadly, as you start thinking about now the actual inventory of all of the other assets that you have in your environment, AWS does make it easier, and all the different cloud service providers, they make it easier for you to at least discover that. They all have robust APIs that give you the ability to understand exactly what your application footprint looks like, easier than anything we ever saw in on-prem networks. So I think that is one of the kind of the benefits of it and how discoverable it is. But the flip side of that is that, the way that I really kind of think about it is really from a code perspective. You've got your inventory of all of your individual functions, but all of those functions are made up of lots of different libraries and dependencies and packages. Mm-hmm. And so now when you start thinking about, well, not just what is my inventory of individual functions, but what is my inventory of all dependencies that are being pulled into that? And I'll go back to, kind of probably one of the most prevalent issues that security professionals remember is the Apache Struts vulnerabilities, where all of a sudden they had to go through and they had to understand, well, where are we vulnerable across our entire environment? Where do we have this dependency pulled into our application because these functions are vulnerable? Now you look at it from a serverless function perspective, and it's gone from just one monolithic application now to hundreds of individual functions that you're having to manage this dependency tree for and understand where you actually might have these vulnerabilities in your environment. So from an SDLC perspective, it becomes, I think, far more complex.
One of the things I'm sort of curious to get your thoughts on, when we started going to, as an industry, heading towards containers, 5-ish years ago, 5-10 years, there was a lot of people going, oh my God, how can we ever keep track of the containers when they're coming up and down so quickly? Mm-hmm. When I was down here, I was trying to track down, there's something I saw in the last few weeks, there's a graphic out there that shows when do you want to use serverless versus a VM versus a container versus these different pieces. But I think what we're seeing is, particularly with serverless, people are realizing they don't have to go all in on a single technology. So more so than in previous lifetimes, for whatever a tech lifetime is, a few years, we're seeing this mixture of 2 or 3 different things. And is that it requires more. The positive I'd put to you is it seems like it requires more diligence upfront when you're actually getting into these technologies. Would that resonate, or do you think it's more people still have a chance to, as they dive in, to sort of come back up and sort of paddle and catch their breath?
Yeah, I think it all depends really, I think, on the teams that are really kind of choosing the architectures in the beginning, and I guess how excited they are about the latest conference presentation that they saw that, basically was talking about how great the world is just going all into serverless or containers for anything else. And, really kind of checking some of that level of excitement that they have and really kind of trying to put in the proper procedures and boundaries around that. I think for a lot of development teams, it's better to dip your toe into the water of serverless, start using it for small individual carve-outs and functions, and then relying on containers really for the rest of the workloads that you're actually running, just because ultimately there's kind of a little bit better of a balance between what we used to do versus what's kind of new here. There's certain types of functions and operations I think work really, really well with serverless. So in particular, anything that's really event-driven in nature, and so pulling records off a message bus or responding to events, serverless is a great use case for that. Increasingly, we're also seeing it used a lot in batch computing, just by the introduction of things like the AWS step functions, which allow you to actually create some really cool architectures for fan outs and parallelism and complex retry logic, things that was previously fairly difficult for you to individually do. Now you have this ability to really kind of adopt those. And so those use cases we do see come up quite a bit as well in those environments. But more often than not, I think for a lot of organizations, it's really going to be highly, highly dependent on the use case itself.
As you're describing that too, you're talking a lot about the learning steps. Learn about just discovering aspects as you move into serverless. Kind of curious of what have you seen the DevOps teams or just developers in general kind of appreciating about security, and how amenable has it been, or what are some good strategies perhaps for just building more security awareness, security intelligence, security skills within the development team, so that they can be. And I'm avoiding the shift in a particular direction cliche here, but I think what I am getting to is, have you seen it, or how have you seen this a shift to serverless just help raise that security bar for developers, just having developers be responsible for security in a way that's positive and not overwhelming for them?
Yeah, it's maybe not out of choice. I think that a lot of them become responsible for security, but it's more of just because there's really no one else to do it. For development teams that are kind of blazing the trail, and they're going and they want to use these new technologies, but at the same time, security teams are still catching up to all of the other, dozen new advancements in technologies and greatest, other things that have basically come out recently. And so they don't have the time to really go into it in detail. And so a lot of times what we find is that security teams are having to go in and basically deputize the individual product security teams or the actual product teams themselves to start managing and building out the actual model for how do we do this. The best example and where we see this really to be successful is when a organization basically builds a center of excellence really around this. And so it's more of a cross-functional team. We've seen this happen, initially with cloud migrations and building cloud center of excellence. And we saw APIs kind of doing the same thing, where teams would build an API center of excellence that would focus on best practices for developing and releasing APIs. And now serverless is really happening. It's the same thing. So you ultimately build this cross-functional team of your DevOps teams, your developers, your security teams, and everyone basically gets a say in the room, and everyone's able to basically go and share knowledge. And by doing this, you're basically able to at least kind of talk about the higher level security concerns, the things that we all care about and have known about for years, but maybe developers don't think about it in this particular way. They don't think about the way that these functions can be abused, and they're really just kind of focused on really the outcomes that they get with it. And this is probably the easiest way for an organization to get started, other than just hiring someone that's a serverless security expert, which I'll tell you, there's probably about 10 in the field right now that actually exist.
Not going to easily hire out of that problem. Definitely. Well, yeah, Peter, you've given us an excellent serverless functions of excellence advice here. I wanted to say thank you for that. Any parting words or things that we, what should we be looking forward to in the world of serverless, or thinking about?
Yeah, so the great thing about serverless, I think, now is we've seen really kind of what doesn't work, and are now focusing on kind of that second generation of solutions that can help organizations go and solve these. And so from Imperva's perspective, we basically have just released now a new serverless protection capability. It's actually built off of our runtime application self-protection technology. And we're really excited about this. We've just released it, and it's also free to use until the end of the year. So if you're interested in trying it and understanding how we can help solve these functions or solve these problems, please just hit up Imperva, and we'll be able to get you started with that. And there's lots of other new technologies, I think, that are starting to go and really kind of look at the problem more acutely and solve some of the pain points that we saw originally.
That's fantastic. I want to say, Peter, thanks once again for joining us.
It was an absolute pleasure to be here. Thank you very much.
Appreciate it. And I want to thank John, and want to give a shout out to all the new people coming by our Discord and saying hi. If you'd like to learn more about Imperva, visit securityweekly.com/Imperva. And with that, we're going to take a quick break and return with news of the week.
Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. We're excited to announce our first round of speakers: David Kennedy, Alyssa Miller, O'Shea Bowens, Marina Sivata, Patrick Coble, Chris Ang, Eric Escobar, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlocked to register and check out our exciting lineup. If you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing and listening pleasure at securityweekly.com/on-demand. Just come over to securityweekly.com. You can find all kinds of fun stuff there. You can also find our previous segment when I was stumbling over how to pronounce the word block or Bach. And John, I feel a little bit less lonely knowing that I'm not the only one making very trivial verbal typos in this sense. But help us out here with this article that you picked up about Chrome and an unfortunate typo.
Yeah, and I'm sorry you've caught my disease of constantly stumbling over words in ASW. So let's see if I can not jinx myself here this morning on that. This popped on my radar probably beginning of last week, and whatever the first headline I saw, it didn't quite have the right combination of words to catch my attention. It was talking about breaking Chrome devices, which I don't care about. But then at some point later in the week, I saw this version which I posted in our show notes, which is talking about what actually caused that bricking was a single character. And in the article, there's a link out to the actual fix on chromium-review.googlesource.com because we're not using GitHub for other reasons. But yeah, literally a single ampersand. So CC is the C++ code. They're doing an if test. If a key data has value and if the key data label is empty, but in the previous version of the code is a single ampersand, which for the pointy hairs and those who don't fully know, a single ampersand in most coding languages is a Boolean and. Is a Boolean and versus and is a logical and. So in other words, you want A and B, not the Boolean mix of A and B.
Bitwise, yeah.
And it's Did I get it backwards?
I just wanted to throw in, the bitwise versus logic is what you're getting. Yes. But you're on a roll here. Keep going.
Cool. Yeah. So, it's funny. I actually caught one of these in a code review myself in the last week or two. Actually, wasn't a code review. I was pair coding with one of my guys, and I'm like, you need another. But it's a hard one, man, because I bet some linters would catch it or some static analyzers will catch it, but this is sort of, if you're, coding, it'd be fun to go back and see when the original code was written, if it was a late night commit. But this is such a simple thing to do. But the end result of that is one little character is now bricked. I don't know what the number is if it's in there, but probably tens, if not hundreds of thousands of devices, right? These things sort of, they sprout like weeds because they're so cheap and they're useful to a lot of people, don't get me wrong. So I see the value in them. It's not really my thing, but yeah. So that's the end of the day. it's easy for us to make a slip of the tongue on Application Security Weekly, but try not to do it in your code. How about that?
Good call. It does also call back to the idea of a little bit maybe of code comments, in the sense of what was the intention of this, code path of this if statement? Are we comparing two different states and we need both of them to be true? In other words, your logical or do we just are we trying to compare actual integers or compare values bitwise and say, are they all zeros or all ones? Which is that subtle difference you're getting to. And to your point, we talked, was it 2 episodes ago, about code comments? I don't know that code comments necessarily would have helped us here, other than explaining we want to make sure that the user, we have a data has a value and it's not empty. But before we go then do some checks on it. But in this case, you also mentioned linting. I know LLVM, for example, will do some complaints. For example, if you're doing some bitwise comparison or in an if statement, and you're not doing necessarily an equality check on it. So this can be a little bit of nothing comes for free, but it's sort of that idea of a coding pattern. Do you want to do a bitwise comparison and have an explicit equality to 0 or explicit equality to 1 for that matter? Or is it intended to be a logical comparison, and we can have our double ampersands? Or honestly, if we talk about, this was the other reason I wanted to mention your code comments. If we talk about readable code, the word "and" can get you pretty far, just in the sense of, oh, right, the word "and" is going to help me out here, and it's going to be a lot easier to understand, and hopefully a little bit harder to make that mistake. So a couple different ways you could potentially turn this into a lesson learned. But that's an unfortunate mistake.
And you're actually, and this wasn't scripted, but you're giving me a lead into something else to talk about. So the code comment, I think, was actually last week. We talked about that because I got a very impassioned response from somebody about this from down in Australia. And so go back and talk about that for a second. What the point I was trying to get across there, in case it wasn't clear at least to some folks, and probably was my fault, was that I'm recommending people to make those code comments for both yourself and for fellow developers. I'm not so much suggesting that by you putting a comment in there in the code about what it's doing, that if you go through a third-party auditor or a security reviewer, that they're going to go, oh, he wants to do this type of thing. Because what if I put the professional code reviewer hat on? I sort of look at the comments and I laugh, right? Because half the time they're not accurate. What you'll frequently see is developers copying a block of code from one place to another and then not changing the comment, which you should be doing anyways. But so it's not so much providing guidance to security teams, it's providing guidance really to yourself or to your other poor fools, either who are working with you or who are going to be joining your company in 6 or 10 months. And one more point, you trigger another brain cell there around the and which is one, and this comes down to a code style thing, right? Which again, we haven't talked about that. Maybe I'll look for a code style article and a few more articles. My preference is if you're doing a Boolean comparison, bitwise comparison, not Boolean, that you would be using a all caps constant, which you are anding in on one side or the other. Because then it becomes very clear. So in other words, I don't want my constants to be lowercase. I want a constant to be clear to be as constant. And then if I'm doing some sort of bitwise thing, use that constant. And that triggered one more final, which I'll say and then shut up, which is if you're doing a large allocation of memory or something, please, for baby Jesus' sake, don't do 20 left bracket 32 to say some large amount of memory. Put it into words so I don't have to actually do some amount of math when I'm actually looking at the code later. And on that, I will give you back the conch.
I will take that shell, John, and I think that's a great setup for a segue into another article you pointed out. So here we have with Google Chrome OS a bit of a snafu that these boxes are bricked until their next. Fortunately, they will do their self updates or self reboots, so they can pick that fix up. But you have here a headline: bugs are more expensive to fix in production. Are they? Maybe not. So this is one of those, maybe this is our thought piece of the week. And I'm curious, why did this one, what was the brain cell that glommed onto this one?
The brain cell that glommed onto this one is I was actually looking for the stat myself. It might have been from my most recent CNCF talk, Cloud Native Security Day talk. There was a talk I did recently where I was looking for the stat because I think in AppSec we quote this one all the time. And for those who aren't, in the Application Security Weekly book and that article club, someone went back and figured out they were looking for that stat also to reference it for someone else, and they realized that the publisher of that stat, which was IBM System Sciences Institute, doesn't exist. So, and this is to sort of we jumped in too quick. The stat we're talking about here, which we always refer to, is a bug in production is 100 times more expensive to fix than it is in development. So really, all the article is saying is that the guy who said that doesn't exist. So someone said that, and we now all say it, and they have some stats around from other people saying, well, maybe sort of, yeah. My gut sense is it's definitely more expensive to fix a bug in see, we did
there it.
We
is.
can't even
it's
speak.
Done. Bingo.
It's more expensive to fix a bug in prod than it is in dev or stage. I mean, it's unless you are an organization that you're able to really do your releases multiple times a day, it's going to be slowing stuff down, right? You're not going to get that fixed, and it has to be prioritized. When do you fix it? Then it has to go through the QA process, and that's going to be slowing something else down. So it's got to be more expensive. If it's 100 times, I think that's the question. But so it was interesting to see this out here, and then to sort of I'll put a follow up on my previous comment. As we are a global, worldwide listened to podcast from Australia and India and all sorts of places, if I comment about baby Jesus or Jesus, I'm not trying to offend anybody. We're religion agnostic, so please take my comments with a heavy grain of salt.
But we will continue to make fun of Perl. Sorry, Perl. On that note, things not written in Perl, but that have contributed to many common weakness enumerations, I picked up the 2021 CWE Top 25. And I think, unfortunately, it doesn't look like an improper use of logical and bitwise operators makes the top 25 list. Might be something hidden in around there somewhere. But clearly, here's a list that is we've talked about in the past. And I forgot to prep our excellent AV team with a drum roll. But imagine, if you will, a drum roll as I pick out rank number 8. Thank you, John. Improper limitation of a path name to a restricted directory, which is a path traversal bug. But so this is pretty neat. And I think the broader aspect I kind of wanted to highlight around the CWE Top 25 is that we have a list of many common vulns. CWE itself and the numbers, I'm just looking around, hopefully no one hears this, but are kind of useless to anyone except for tracking statistics. So if you're trying to build out a security education program, there's no point in saying here is the CWE number, here is the CWE nomenclature, for example, necessarily. Just pick out some example bug classes like an out of bounds read and write and say, we want to get rid of these because we are a C++ shop, or we have a language that lends itself to these types of problems. Or we want to get rid of path traversals, so we'll build a framework or build some education around the type of attack like that. So those are some of the things that I wanted to highlight initially about this list. And there's a couple other points I'll come around to, but John, I'm not sure if you had a chance to see all of the top 25 and if you have your own favorite on this list as well.
I was eyeballing it. I'm still a big fan of null pointer dereferences. They're sort of, they tend to crash more than anything else, but it's one of those things where, especially for these, a good portion of this is C or C++, or it's a pointer-based list to a degree. And I think, even in Go, we can still get nil pointer references. So it's not just purely C, but that's one of those ones that some other languages are going to be a little bit better at actually catching and stopping them and the compiling and the tooling. But I still see a good number of folks making those. And I think, just go through this really quickly, right? So it's not going to be too quick. But there's a good number of them in here. Overflows, deserialization, null pointer we mentioned, memory buffer bounds. I couldn't say default permissions, but I probably could say one more. XML, entity dereference. A good number of these are pointer based in one way or another. And I'm being very loose. I recognize when I say XML dereference is a pointer thing, but work with me. It's application security. And so, but So there's some things in there which are as a class, talking about CWAs that you want to attack. But I think what I really liked about this is just it's in a table that I can see the top 25 in one screen and sort of eyeball it from going through 20 pages, but not so much from a 20-page point of view, but just as you look at this in a little more concise format, we can do conversations like what we just did. Interesting to see the ranking going up and down in some of these as their importance changes over the years. So yeah, it's worth about as much time as we just spent talking about it.
Well, I'm going to sneak in a little bit more time to talk about it, but I do agree with you. What I'm going to sneak in here too is I would be very curious about the age of the code that where these vulns are being found in, especially on the compiled code side of things, the C++. That are we just getting better at finding these now, or researchers are just getting more focused on we want to dive into this particular area of the kernel or this particular aspect of the browser, or whether it's an older version of a browser or a new one. And where I'm going with that is the idea that there's a good mix of compiled code, the out of bounds, integer overflows, etc., and the web-based code, SQL injection, RCEs, XSS is up there at number 2, as well as path traversal and CSRF. So web, and there's a lot of vulns here that are relevant to the modern web, including serverless for that matter too, as a callback to our last segment. But to finish my original thought, I would just be curious if, LLVM, and I'm sure GCC has equivalent, I just can't recall it off the top of my head, has a lot of the sanitizers, address sanitizers, undefined behavior sanitizers. And if you're compiling your code and turning those on, a lot of these should at least trigger, fingers crossed that I'm right saying this, some complaints from the compiler, or at least the compiler pointing out that says, this looks a bit wonky, this might not be right. And hopefully we can just see the tooling help us both to identify this in legacy code so we can fix it, or ideally prevent it going in the future, so that this CW Top 25 for 2022 might have a different type of representation on it, in the sense of what might be prone within particular programming languages, or that web versus client-based or compiled types of applications.
And if I could spend to give it a few more seconds, what I was doing there as you're talking, I'm like, how about let's just look at the top 5 and sort of think about what's in that list. Mm-hmm. And as I focus down and think, I'm going to petition to change my favorite to actually be what's number 2 on this list, which I think should be number 1. So out of bounds read and write. Is that really an issue in 2021? I think that, as you mentioned, legacy issues, I think that's where that comes into me. But number 2 is actually number 2, 5, 6, 8, 23, 25, and possibly 24. In that, from the point of view, if you're actually sanitizing the input you're taking from a user, whether that's coming from a web interface or anything else, that's going to capture quite a lot of this list, right? So it'd be interesting to do a little survey here if people want to hop into Discord or YouTube or give us feedback anywhere. And don't forget, like and subscribe. But it'd be interesting to see what type of apps are our listeners writing. From the point of view is, a lot of stuff that I've been doing the last years, beside, some heavy duty back-end containery type stuff in low-level C languages, a lot of the stuff that we do really day in, day out is web interfaces, right? And, APIs and stuff like that. So that's where I think people should really be focusing on the majority of the time in 2021. So it'd be interesting to see how the rest of the world thinks about that.
Would be curious, and I'll go as we continue to extend what was going to be. This is our CWE Top 25 minutes discussion now, apparently. But with cross-site scripting, that's where I go back to my old canard of use React, use the framework that just makes it hard. And even with command injection, both OS or just process, CLI commands, as well as SQL injection. Most, if not all, of the modern programming languages have parameterized ways to build commands, whether it's obvious the parameterized queries in SQL, or just here is your process name and your argument list being passed on to it. So I would almost even argue that you don't have to worry as much about the input validation as you do just use the correct templated type of function. Now, obviously, there could be some nuances in there, and I'm sure our good listeners could find out some exceptions here. But I feel strongly that we have those capabilities in place. So it seems like 2, 5, 6, 25. Those are the OS, a lot of the command injection and cross-site scripting should actually just be gone away because we have the tools to get rid of them.
Yeah.
Oh, and yeah, I think you might have had another thought in there.
Oh no, you said 2526 or something. I just said hike. It's a dumb joke.
Bringing you dumb jokes and top 25 lists. One other thing I will add, I did come across, so the Google Project Zero has a website on their GitHub page for root cause analysis, 0-day RCAs. And I just wanted to highlight that as a good reference because if you're curious about actually out-of-bound writes, you can find a relatively recent one in Internet Explorer. And they have a couple other examples of use after free and a lot of these compiled types of flaws because they're looking at a lot of Chrome, a lot of browsers, a lot of OS or kernel types of 0 days. And so I just wanted to throw that out as an extra reference. Check it out in the show notes if you want to find just how to demonstrate a out of bounds write in 3 lines of JavaScript. Is pretty impressive, and it can be really good as an educational piece if you want to say, here's what's relevant, here's what modern types of flaws and attacks look like. So I'm going to put my foot down metaphorically and say, yes, let's move on from the top 25 into a real quick comment about a bug still. This was format string, which I forgot to see where the format string lists falls into the list of the CWE top 100 maybe. But we talked last episode, I forgot now, about the iPhone bug and the Wi-Fi network that could have %s, %p, %n, and so on. Someone apparently was able to turn that DOS against a device into an actual full-on code execution. So pretty cool. And I just want to highlight that as kind of an aside that bugs should be fixed, and that there's a crypto, as in cryptography, comment or tenet that attacks always get better. And in this case, an attack did get better, not in the sense of the cryptography aspect, but just the turning a DOS into a code exec. So something to be aware of, something to point out. The other thing I did want to, so we've been talking about flaws, and I'm going to use this to go and talk about one of the other types of security events that are going on within August, which is the Usenix conference. Now, this is a bit more academically oriented conference because all of the papers are written in LaTeX and 2 columns, and everybody shows off how they can do proper formatting and footnotes, which, don't get me wrong, I do appreciate footnotes. But I went through a couple of the presentations that are coming up in August, and there was one that I thought was really neat, finding bugs using your own code. And it has a bit of a clunky acronym, this detecting functionally similar yet inconsistent code. Now, the basic premise is, and I have to do my hand wave, the Kinsella-proof hand wave, because we're going to machine learning, exactly. Yeah. But they're mentioning, rather than saying we're going to have the magic of machine learning, we're going to train this on a massive amount of data and code out there, they're saying, look, you have your code. We're just going to train on your code. We're basically going to build the AST, that abstract syntax tree, and we're going to look for semantically and logically equivalent snippets of code and compare them and say, it looks like you have a couple of if statements. You're using the correct type of ampersands in here, or double ampersands. And it's semantically, it's working on the same types of variables. But, oh, look, you forgot to do a free on your string. So maybe there's a memory leak here. And, that's a memory leak, and that could lead to potentially a DOS, but there could lead to other types of problems. So what was really neat to me is that if we step back and say, what's the take-home message, or what could somebody do when they read through this or think about this, is not go and roll your own ML and figure this out, but in the principle of, if you had a bug bounty report come in, or you have one of your own scanners or your own AppSec team find a particular bug, are you able to describe semantically what that bug looks like within your code? And can you find similar areas where their vulnerabilities might be? So it's the idea of, rather than playing whack-a-mole with bug bounty and say, oh, we fixed that once, now we got another report, we'll fix that one, another report, we'll fix that one. You say, we got one report, is this a fundamental flaw, and are we able to search the rest of our code for this particular type of category of flaw? And to me, that's something that I think is unfortunately a little bit easier to say than do, but I think it still can be done with a team. And hopefully this type of research leads to better tools to be able to do this with a semgrep style functionality that can make our code better.
I was just about to say, somewhere the semgrep guys are raising their hands going, me, we can help.
Indeed they are.
I haven't read this whole thing. I want to read this whole thing. It's super interesting to me. I know it's definitely a serious paper, because not just does it have the look of a paper written in LaTeX, but I also see the mention of NP complete in it, so it has to be a serious paper. But no, this is a super interesting topic, right? As you're talking, I know Golang CI, one of the linters for Go, that will catch duplicate code. I'm not sure how far away it checks. Mm-hmm. But yeah, because the problem I've run into with some projects is, you grow your team too fast, or maybe not too fast, but you grow your team. There's different people writing code. 2-3 folks implement the same thing because they can't find the other one in the code. Then when you go to try and figure out which one you want to use, back to my commenting comment, if the comments aren't accurate in saying what it actually does, you might pick the wrong one. Or maybe one was written by a senior guy, one was written by a junior guy, one has a bug, the other doesn't. It gets sort of tricky, right? So it's a fairly important thing. If you're doing sort of the modern startup mode where you have like 1 or 2 senior angels, and then it's not just a startup thing, right? Everyone does this. And then like a team of more medium and junior developers, how do you sort of really keep eyes or keep tabs on what's going on? So this should be a good read over something strongly caffeinated to keep me awake.
Indeed, good read. I appreciated too that they focused and they demonstrated the success of this, the utility of this against in this case QEMU and OpenSSL in particular, and discovered 22 new unique bugs. And just at a glance, they looked like actually meaningful bugs and useful bugs, rather than just like, oh, that's not even on a code quality aspect. That's just like yeah, sure, that should be fixed, but it's not something that gets me interested or excited. So big thumbs up to this research. Hope to see it turn into tools, because I think that would be the other thing, is that this summer comes along, we see a release of tools and presentations, and then a month later, we're on to the next big and interesting thing, and those tools and projects start to collect dust, and we don't improve the baseline of security, and that's what I would really wish to see. So I'm fanning, being a fanboy on this particular paper. We'll see what happens. The other thing I'm a fan of is Qualys has been doing a lot of really interesting work, poking at some really interesting edges and dusty code areas of the Linux kernel. In this case, they have Sequoia. And for those of you out here in California or who enjoy some redwoods, the Sequoia sempervirens, great trees. So an excellent named vulnerability for this one. But what they discovered was basically a type conversion error. So, hey, CWE top 25, here is an integer overflow. They went from size T to int, or basically unsigned to signed, and bad things happened. And once again, this was local privilege escalation, which, sorry Linux, I think local privilege escalation are possibly a dime a dozen. I'm not sure what the economics is these days, but I think the inflation is still on my side, at least in theory. But this type of type conversion, as I'm not making puns intentionally, is one of those things that compilers should be pointing out, or linters or semgrep, as we just mentioned, can find these types of patterns and hopefully go in and say, hey, I'm comparing size here. The size of this object, in this case, a path, a depth of a path or a path name, for example, or maybe it's something that could be coming across in a packet. But if this is an attacker influenceable size, that's probably something that should get more scrutiny and have a little bit of extra care into this, whether it's signed to unsigned conversion or making sure it does a safe int or adjusting your pattern a little bit so that when you do that signed to unsigned comparison, that you're doing it in the secure manner.
Yeah, another good Reddit from Bharat Jogi and the team over at Qualys. They keep doing this. We're going to have to turn this into Qualys Security Weekly. Then we're going to have to charge them more for how much they are a sponsor, but lots of great stuff as usual. So, yeah, I was digging into the code on this one last week when it came out. It's one of those things. I think this hits you more in a C-like language where you really care about the size of your data structures, right? So I think that's part of which actually starts throwing you off, and as you start doing type conversion back and forth. I'm wondering, for existing packages out there, how many are actually going to be sincerely vulnerable to this? So the Linux OS is vulnerable to it. I believe they've got a video in here, right? Of the walking through the POC, or to have the code for the POC is pretty simple. Just forward down and create a bunch of directories and then bang. But for an existing, I'm familiar with one open source project that took a step back and go, okay, do we need to patch this? And the conclusion, which I think was legit, was no, it's not going to hit us. So you have to have a situation, if you don't have a shell or something on the box, where you're able to actually create that many directories. So this is a really interesting one because it's privilege escalation. It's pretty easy to execute, but still you need to be in a position where you're able to actually, even if it's imagine you have like a web call where you're creating a directory each time. So you're basically going to have to DOS the system to create enough directories in the first place to create the DOS or the permission execution. So it's an interesting one to think about. When do you actually patch something like this when do you patch something like this ASAP because it's going to be a big deal versus we're going to get to this in the next release, I think is how you'd approach it. So we're doing lots of thought pieces today, and I think this is sort of one of them in a way.
It is, and I love the direction you went there, because I would just expand that into that basic kind of bug bounty triage, if you will, or just you running a SAST or a DAS scanner for that matter, in the sense of, is there a code path to this vulnerability? Is there an executable path that's open to an attacker? And that's not clearly, we're not saying you don't need to patch it. We're just saying, when do you patch it? And that code path or that exploitability, if you can get a good sense of it, can inform that decision, especially if you're running a system that's running as root. Local privilege escalation doesn't really make a difference. As well as, too, if you're going to end up DOSing the system before you even get to that local privilege escalation, doesn't matter. You actually maybe want to start addressing that the brittleness to if it can be DOSed. So good ways to think through a vulnerability. And I guess what I'd say is this is our magic of threat modeling, the vulnerability. How much do you care right now to expend those engineering resources? Which I think we're getting close to the end of time, but I do want to hit at least on this transparency report from Twitter. And really just one single percentage that they called out is that 2.3% of their users have adopted MFA. And of that group, basically 80% of them are just using SMS to FA. So it's one of those aspects where it's really easy for us on Application Security Weekly to say, use input validation, deploy MFA, and you're done there. And then the episode's over, and we don't get to make any references to New Wave post-punk or what have you. In this case, it's great to say we have a 2FA or an MFA solution, but if nobody's using it, oops, how good is the solution? Or, we need to figure out as a security side, maybe product security or security of products, or take a product approach and say, what's the hang up here? What can be the driver to increased adoption? Because I think clearly we know that is a great way to prevent account takeovers and to minimize how many people reuse passwords and so on. But if we're only doing this work for 2% of the population of our app, clearly we have to figure out how to influence that number or set our sights elsewhere to tackle some other aspect of this. And I'm kind of running out of ideas, so that's why I'm going to have to save me here, John. What's the solution here that we can get this 2.3% to at least 2.5%?
Stop using Twitter. Okay, let's see if I can come up with a slightly better one. Yeah. And I use Twitter. I can't. No, it's I as soon as you said percentage, I knew you were going to go after that 2.3. It is what it is. And I think, to take a step back and expand, this is actually, it sounds probably sort of shocking to us, but this is the world, right? So this is, of the applications that we talk about on ASW, this is probably one of the more commonly used by end users and consumers, right? So the question comes down to, how do you get that group of folks? We're not talking about enterprises or banks or, right, a lot of stuff we generally talk about or we think our listenership is around, but this is that general endpoint. How do you get someone who wants to post the latest thing about, pick your controversial subject, how about we just say that? And does that particular person and their mindset want to go and pull out their factor to be able to, not so much to tweet, I get that, but even just to log in and register the app on their phone or their whatever. So I think that's the sort of state of the problem, right? It's not so much what Twitter's doing or how they're doing it, and that's why they allow you to use SMS, because they're trying to make it as easy as possible. But even at that point, people are going to be hesitant. So we've improved. They increased their usership by 10%, almost 9.1%. But how do we really get that group of folks to embrace basic identity verification? How about that?
Yeah, and not controversial, but definitely Team Free Britney. So there's my Twitter topic for the day. But I say, yeah, to your point, we can say zero trust is a great thing. Adopt zero trust. Throw out FIDO hardware keys, YubiKeys, etc. to all of your developers. Boom, your problems are done. Well, that's great from the supply chain perspective, from your SDLC perspective, but hopefully your application security threat modeling and your purview, your charter, is still for your users and their data, whether they are being potentially exposed to fraud because you can do money movement over a particular application, whether they're being exposed to abuse and picking up on the controversial topic of the day, such as, is Perl readable by anybody but the person who wrote it? Those are the things that you're getting to. So, yeah, yeah, go ahead.
A real quick one on this. While we sort of snark and haha funny and Twitter and all that.
Yes.
Somebody was sentenced, I can't remember who he is or where it was or the details, so I'm going to forget it, but at a glossy high level, somebody was sentenced to prison in last week for murdering someone for their Twitter handle that they wanted.
Yeah. So
this is still sort of a deal, right? And I'm not saying that 2FA would stop that. Might have slowed it down, I guess, but for some things, even, and we're not talking about going out towards some of the uprisings we've had around the world, which Twitter has, I don't want to say empowered, but help people find each other and create that community. Just the basic thing that some dude had a Twitter name that was cool and short, or I don't know what the name was, but someone else wanted it, and they shot the poor bastard because of it. So these are important things to some people. So how do we, it's even the most simple things. What I'm basically saying is even the most simple things, if we take a step back and think about how we threat model it, there's still a lot of value, a lot of importance around some of these.
Absolutely great point about that. It's the threat modeling aspect, because who would have predicted that the 2-letter and 3-letter Twitter handles are that valuable, especially to influencers or just gamers or other groups who want to highlight or show off a particularly vanity handle, if you will. Same you'll see within squatting on a lot of different any type of new social media enterprise that pops up. That's a great topic. We'll have to figure out how to bring in some more threat modeling on product abuse. It's one of those topics that I've tried to pick up in 2021 and bring in a couple articles kicking off from January and a couple other times. So I think there's some product abuse that we'll bring on later. I did have one final article. Don't know that we have too much time to talk about it. It was more about, it's a little bit of marketing fluff, so that's also why we don't need to talk about it in too much detail. But it was about from Google Cloud and their CISO, Phil Venables, who we highlighted a article from him about complexity and security and the role of design in making those two actually work better together. But as a follow-up to our last week's discussion about clouds and risk, and availability, this is just a couple food for thought on compliance in the cloud, telemetry in the cloud, and basically one of the things that I'll just kind of highlight is that reducing the cost of controls. So just making it easier so security can be a natural, easy a cost-effective step for dev teams to roll out. And we could potentially, to tie back into just our previous discussion there, the idea that SSO for enterprises shouldn't be extraordinarily, an added expense for your SaaS. There's a whole SSO.tax website out there tracking this type of aspect. So those are my thoughts on the Final Cloud article. John, any parting words either on that or anything else about what we talked about today?
Not so much on that, unfortunately. It's paywalled, and I love my friends at CSO, and I've both written for them and done talks with them, but your site's paywalled, guys. And I should have a login, but I actually can't find one right now. But what I would recommend to folks, we were talking about serverless earlier. If folks want to get involved in that, Cloud Native Security is doing a white paper around serverless security. So either hit me up on one of the socials or go check out the CNCF Slack. Love to have more input on that. They're doing a ton of great stuff. I've been talking a lot about CNCF recently, Apache, all sorts of different open source things out there. Help out where you can and sort of help make all of us a little better.
Help us improve those security baselines. Yeah, hop onto Discord and ping John. He'll be happy to connect you with all the great information, just as we are always happy to connect you with AppSec information on a weekly basis. Want to thank everybody for listening. Want to thank John once again for joining me on this news segment, as well as our talk with Imperva and Peter talking about serverless. We're going to take a week break now, so we'll see you next week on Application Security Weekly.